Hello, my name's Paul Geyer, and I will be chatting with you today about principles of sustainable design for buildings. By way of introduction, just a little bit about me. For 35 years, I was what I characterize as a straight-ahead designer, designing buildings and related infrastructure. For an additional 9 years, I was in the public policy arena as a principal staff advisor to the California legislature on capital outlay and infrastructure issues, which included at that point in time sustainability and green design and environmental concerns and all that sort of thing. It was fairly hot political topic in California at that time. And I got registered in a few different things along the way. The first question that might be asked is, first of all, this webinar is talking about sustainable design for buildings. There are, of course, lots of other infrastructure design situations where sustainability would be an issue, but I'm talking just about basically buildings. So a question that could be asked right up front is, well, what's the big deal with buildings? So are buildings a substantive consideration when you talk about sustainability? Well, now, and sustainability, of course, we're talking about the big concept that we are riding along on this planet that has finite resources, only a finite amount of coal, finite amount of oil, so on and so forth. And the idea is that we should try to not use up our resources any faster than is necessary, and that we should try to not use them up faster than the rate at which they are naturally replenished. So are buildings consuming these natural resources? Oil, gas, water, so on and so forth. Well, some numbers have been developed and have popped up in the literature. I'm not sure exactly where they originated. It might have been from the EPA. But these numbers tell us that buildings consume 39% of total energy use in the United States. They tell us that buildings consume 12% of total water consumption. Now, that I think might be a little bit misleading. It's probably more appropriate that to say that buildings utilize 12% of total water utilized. But a lot of water gets utilized, but it doesn't get consumed because the water system on this planet is, of course, kind of pretty much a closed loop system. Rain falls out of the clouds, collects in streams and rivers and so on and so forth. Humans pull some of that water out, treat it, use it, treat the wastewater, dump the water back into the river or the lake or the stream or whatever. It flows to the ocean, evaporates, goes up in the sky in the clouds, comes back down as rain, and just keeps looping around. So a lot of the water that is utilized is not necessarily consumed. A certain amount, a relatively small amount, is going to be consumed in biological and similar processes, plant growth and this sort of thing. But in any event, a substantive amount of the water is being utilized, and where the Earth's resources are primarily probably being consumed is in the treatment of the water, both the treatment to make it suitable for human consumption and to treat it, the wastewater, after humans get through using it. But in any event, this is the number that's popped up. These numbers that have popped up also indicate that 68% of total electricity produced in the United States is consumed in buildings, and that's a pretty big number. Also, along with these numbers, there's a number that says that buildings cause 38% of carbon dioxide emissions. Now, this, of course, is not consuming carbon dioxide. It's just that carbon dioxide has been identified as being an undesirable product to be released into the atmosphere because of the allegations of global warming and so on and so forth. So, for what it's worth, that's what this number says. So you take a look at all of these, and they're pretty big numbers, and so you would have to probably conclude that if they're reasonably close to the real situation, that yes, buildings are a substantive force in the big picture of sustainability and the consumption of the Earth's resources. So that would lead us to believe that we as engineers should be paying attention to this consideration in what we do, which is design things that, of course, consume resources in various ways. From my personal perspective in my career, this strikes me as about the third public policy agenda that engineers have been tasked with over the years. Back when I got started in this business in the early 60s, when an engineer got a project that came into his office or across his desk, he just sat down at a drawing board, cranked out the drawings, whipped out the specs, and that was the end of it, and the project ended up getting built. Long about the probably the 70s, the early 70s though, the public policy concern about environmental impacts cropped up, and there was great debate about it in the public arena, and there still is today. And engineers were looked at and with kind of a accusatory way, and were told, look, when you undertake to design projects, you need to take into account the environmental impacts, the public policy concerns about environmental impacts. And okay, that's a public policy concern, so we engineers will certainly address that. But the problem was that back at that time, it was not crystal clear, as a matter of fact, not clear at all, what engineers were supposed to do to address these environmental impacts. And it took a few years of thought and experimentation and so on and so forth to kind of gel on what it is that engineers should do to address this public policy concern of impacts on the environment. And the end result of that was the development and institutionalization of environmental impact reports, environmental impact statements, negative declarations. So all of that finally got worked out, and now there is a pretty well-defined process that engineers need to go through to address these environmental impacts. Moving on to the late 70s, the next public policy assignment that engineers got, as I see things, was that and it was energy conservation. And this came about because of the energy crisis back at that point in time. This was a public policy concern that engineers could understand right off the bat and could address expeditiously. Engineers know about the efficiency of boilers and HVAC systems and motors and so on and so forth, and electric lamps. So this public policy agenda, conserve energy, was one that engineers were able to hop onto and address expeditiously. This third one, sustainability or green design, it really kind of seems like a reprise of the environmental impact concerns. But this is the way in recent years it's been enunciated by those in the public policy arena, the members of the public, their elected officials, so on and so forth. And there has been some confusion about what engineers are supposed to do to be responsive to this public policy concern about sustainability. And back in around 2006, the federal government, which is, we need to recognize, the largest designer and builder of buildings, certainly in the United States and probably in the world as well, stopped, took a deep breath and said, well, okay, you in the public policy arena are telling us in federal government that we need to be responsive to this idea of sustainability. But what exactly are we supposed to be doing? And by the way, I never, although I will be talking about the federal government here, and it's, but I never was an employee of the federal government, never worked for the federal government. When I had my own architectural engineering firm, we did a lot of contract work for the federal government, but I was never an employee, so I don't have any special allegiance to the federal government as an institution. And of course, the big actors in the in this arena in the federal government are the Department of Defense components, particularly the Army Corps of Engineers and the Naval Facilities Engineering Command. Anyway, back in about 7 or 8 years ago, the federal government said, well, look, what are we supposed to be doing? And they established and convened a task force with representatives, at high-level representatives, from all of the federal agencies with substantive building design and construction programs. And all of these agencies were represented. Again, the big actors in this area are NAVFAC and the Corps of Engineers and the Air Force Civil Engineers Office. but other agencies, General Services Administration, Veterans Affairs, Department of the Interior, we're all represented on this task force. And they came up with a report, and in the executive summary of that report, I thought they came up with some very good words. And this slide that you're looking at now is taken directly from the executive summary of the report of this task force. And there are certain words that I really like in this statement. And those are, it starts out, sustainability is an ideal. And I think that's an important point, is to understand that goals, that principles of sustainable design, they are goals to work towards. Hopefully you may be able to achieve them to some degree, but maybe you won't. But at least that's what you're supposed to be doing. You as engineers are supposed to be doing, is working towards these goals. And they are ideals, and you should do your best to try to reach those goals. Then the next sentence also has some very good words in it, I think. The real-world implementation of sustainable building relies upon balancing the environmental, economic, and social impacts. And this is very important for engineers to keep in mind. The environmental impacts, those of course are these principles or things or goals that you want to achieve in the area of sustainability. But you also need to keep in mind the economics of your project. In other words, you don't have an unlimited budget. No project does. And you can only do a limited amount with a budget, with a fixed budget for a project. And third is the social impacts of what you do. You can do a lot of things that on a project that would be helpful in moving towards a sustainable design or a sustainable environment, but you would be have very dissatisfied occupants and visitors to your buildings. Like, as a simple example, you can significantly reduce the natural resources that you consume by deleting the air conditioning system from your building. Big saving in energy, big saving in the resources that are needed to generate the energy to run the air conditioning equipment. But if you do that, you're going to have very dissatisfied occupants in your building. And you have to not lose sight of the fact that of the reason that you're designing the building in the first place, and that is to provide an environment that will be healthful, safe, efficient, and pleasant for people to work in, visit, live in, etc., whatever they're doing. So these, I think, are very good words that this federal task force came up with. Sustainability is an ideal, and the real-world implementation of sustainable building relies upon balancing the environmental, economic, and social impacts. I think those are important ideas to keep in mind as we go through this discussion. Now here is how I see what I will be talking about today, how I will be structuring what I'm have to say. And it's at three levels, you might say. First, I will be talking about principles. What are the principles of sustainable design? What are these goals that you as engineers should be attentive to in the design of your projects. Secondly, for each of the principles that we identify, what are the opportunities that may or may not exist on your project to do something in furtherance of one of these principles of sustainable design? And then third, I will be pointing you towards some resources that are available to you to help you in implementing opportunities that may exist on your project. Now, a word here about these resources. They are largely federally generated resources generated by some agency of the federal government. The Department of Energy is a major source of these resources. The Environmental Protection Agency, of course, is another one. And then the major designers and builders of buildings, Corps of Engineers, NAVFAC, Air Force Civil Engineer, General Services Administration, Veterans Administration, etc. Those there are resources that come from them. So this is what I'll be talking about, is the principles of sustainable design, opportunities that may exist on your project or they may not exist, and then resources that are available to you. By the way, another reason for pointing you towards these federally generated resources is that they are almost all available for free, and they are quite accessible via the internet age that we are in. And these resources are in the forms of manuals, guides, databases, perhaps some computer programs that are downloadable that will do this and that. So this is how what I will be talking about will be structured today. So the first question is, okay, well, what are the principles of sustainable design? And this federal task force that I've spoken identified 6 principles as being the principles or goals of sustainable design. 1, employing integrated design. And I must confess, I don't know what is meant by the term integrated design. So that raises a question in my mind. What are you talking about? Secondly, optimizing energy performance. This is very understandable. Design your buildings and your systems so that they can require as little energy utilization as possible, and therefore the consumption of natural resources, oil, gas, coal, will be reduced. So that's understandable, and that's certainly logical. Number 3, protecting and conserving water. Again, I think we have to recognize that the water system on the planet is kind of pretty much a closed loop, and that really what we're talking about is more utilization of water, and that where the water gets, or where the Earth's resources get consumed, is in the treatment of the water, treatment to make it safe for humans to utilize, treating the wastewater, and then other things that need to be done to capture the water, build dams, reservoirs, etc., this sort of thing. So that's understandable. It's a little not crystal clear, not as crystal clear as optimizing energy performance, but it's understandable. Number 4 on the federal task forces list was reducing the environmental impact of materials. Now, those words are a little squishy, but really what's being talked about there is recycling, utilizing recycled materials in your design and then incorporating features into your project that will allow perhaps features of your building or your infrastructure to be recycled at some point in time in the future. And then fifth, enhancing indoor environmental quality. And this one, at first glance, you might say, well, I don't quite get what that's got to do with sustainability. But what that is a statement that you must not lose track of the reason that you're designing the building in the first place, and that's to provide an environment that is efficient, safe, healthy, pleasant for the building occupants to live in and live and work in and visit and so on and so forth. So that's really what is meant by those code words, enhancing indoor environmental quality. So these are the 5 principles of sustainable design for buildings that were enunciated by this federal task force. And again, I think they did a good job of addressing this issue at a high level. Now, there is a second list of principles that has popped up in the literature that is pretty similar to that which was produced by the federal task force, and it looks like what you see on this slide. Optimization of site potential is number 1, and that replaced that rather squishy one about using integrated design, whatever it happened to be. And this is understandable. You have a given site and it has certain features, and there are different ways you can utilize the site, where you put the building, etc., etc., etc. So that's understandable. And number 2 is the same as number 2 on the federal list, optimizing energy use. That's good. Number 3 is the same as the federal task forces list, protection and conservation of water. Number 4 is comparable to that on the federal task forces list, selection and use of environmentally preferable products, the recycling business. 5, enhancement of indoor environmental quality. In other words, don't lose contact with your reason for designing the building in the first place. And then a 6th one that is added on in this list is optimization of operations and maintenance practices. And yes, we are designers essentially, although of course many engineers are in the O&M end of things, but I'm speaking from the perspective of a designer, which is what I've always been. So optimization of operations and maintenance practices, we as designers need to recognize that and be responsive to that, because there are many things that we do in the design of a building or related infrastructure that affects and may control what the O&M people can do once they take over the building for operations and maintenance. So that seems like a good one. So you've got these 2 lists that have cropped up. The one on the left developed by the federal task force. The one on the right, I'm not sure exactly how it came up, but it is what it is. And the two lists are remarkably similar, with the differences noted here with the underlining. And in my view, the list on the right looks a little better. And so that's the one I'm using in what I'm talking about today. So the principles of sustainable design of buildings, and remember I'm talking just about buildings, has 6 principles or goals: optimization of site potential, optimizing energy use, protection and conservation of water, selection and use of environmentally preferable products, enhancement of indoor environmental quality, and optimization of operations and maintenance practices. So these, in my view, are the 6 principles of sustainable design of buildings. And that's what I will be talking about, and I will be, as we go through these 6 principles, I will undertake to point out some opportunities that may or may not exist on your project for you to do something in furtherance of one or more of these principles of sustainable design. And by the way, that's something to keep in mind. Some of the opportunities that I will identify are exist and will do something in furtherance of more than one of these principles. And those opportunities you should probably look at most closely when you are making your decisions about what features to incorporate into your project, because by incorporating a given opportunity or taking advantage of a given opportunity, you can do something in furtherance of more than one of these principles. Therefore, you are getting more bang for the buck, and that is obviously helpful in recognizing that the addressing of the sustainability issues is a combination of is a balancing act, balancing the 3 concerns: environmental, economic, and the environmental quality, the quality of the environment for the building occupants. And now we will move forward and look at these principles. For each principle, we will look at some typical opportunities, something you might be able to do on your project, and then I will be pointing you towards some resources that are available to you. Again, they are largely federally generated resources, but don't be turned off or concerned. Now let's look at the first of these principles of sustainable design, the optimization of site potential. You have a given site, but there are things in almost all cases that you can do with the site. You have different choices. One of the opportunities that may exist on your project is to minimize development of open space. There's kind of an underlying principle. It's hard to quantify it, but it's generally recognized as being valid, is that the less you disturb the natural environment, the better that will be from the standpoint of the objectives of sustainable design. So, minimize development of open space. Well, one way that you can do that, of course, is to reduce the footprint of your building. And so if you need a 50,000 square foot building, it can either be a one-story building or it could be a five-story building. If you make it a one-story building, you are going to have a footprint of 50,000 square feet. If you make it a five-story building, your footprint is only going to be 10,000 square feet. Therefore, you may be disturbing less of the open space and the existing natural environment. So reducing the footprint of your building by going to multi-story may be an option, but it may not be an option also. Another excellent way to minimize development of open space is if you need a certain amount of space for a certain activity or business or residential community or whatever. Perhaps you can, instead of building a new building, renovate and possibly expand an existing building. That way you would also be minimizing the amount of open space that you were disturbing. Also use previously disturbed land. That may be an option. You need to build a new building. Your options are to build it on a nice pristine natural meadow with lots of little wildlife running around and this sort of thing. And the other alternative is to build it on the site of an underutilized parking lot at your activity, whatever it is, college campus or so on and so forth. So if you build it on the previously disturbed land where the underutilized parking lot is located, then you can leave the pristine meadow undisturbed, and that is generally recognized as being something that's useful in working towards the goals of sustainable design. This is just an example of quite a nice looking renovation. This was at a Navy facility in the Washington, D.C. area. There was an existing unused gun turret plant. The demand for gun turrets not being what it used to be, the plant wasn't needed for that purpose. The building wasn't needed for that purpose, but there was a need for engineering and administrative offices. And so this building, rather than building a new building to meet that need for space for engineering and administrative staff, the gun turret plant was renovated. And as you can see from these two photos, it's quite a nice renovation project. Attractive exterior, and looks like a very pleasant working environment on the inside as well. Something else that you can do to optimize the site potential is control erosion through landscaping practices. This may be an option on your project. And the underlying principle here, and again, it's difficult to quantify it, but it's understood and appreciated that controlling erosion will, in its own way, work towards the achievement of the principles of sustainable design. There's kind of an underlying thought here, and that is that whatever comes onto your site naturally, you should try to leave it on your site. And so that means the soil that's there on your site, keep it there. Or water that falls on your site in the form of rain, generally speaking, keep that water on your site so that arrange things so that it percolates into the groundwater or drains into an existing drainage channel or creek or something like that. And as far as corrosion is concerned, or erosion, the landscaping, of course, is an excellent approach to this because it's quite well recognized and verified and documented that vegetation holds the soil, the roots of the plants hold the soil together and keep it in place. And you can assist in keeping this soil in place by perhaps grading vegetated swales and depressions and things like that to hold the water on the site and the soil on the site and prevent it from running off, because if the soil erodes away and leaves the site, it ends up in the stormwater management system of the surrounding municipality, and in its own way that's going to consume some of the earth's resources. Here are some of the typical ways of doing this. Of course, this is just a drainage creek or channel with vegetation planted on the slopes. Also, you see that they've used some geotextiles to hold back erosion that might occur during rainy seasons typically. So this is something you might be able to use. Mulching is a landscaping methodology that of course is used to bind the soil together, and that's an option perhaps. Hydro seeding, a pretty cost-effective methodology for seeding, landscaping large open areas. That's an option. Here is a nice little product that can have its applications. These concrete paver units, which when you put them in place, they have these holes in the concrete paver blocks. And so vegetation can take root in those openings. Rainwater can percolate down through these openings in the rainy season and into the groundwater, but yet you still have a surface that has some structural integrity and can function for pedestrian traffic and probably for a certain limited amount of vehicular traffic as well. And so rather than paving this entire area with asphalt concrete and with the resulting sheet drainage that occurs with asphalt pavements, you would be using these paver blocks. The cost would probably be greater, the initial construction cost, but if you've got the money in your budget, this might be an option. And it provides an attractive landscape feature. We've all, I'm pretty sure, probably seen a number of these installations, and they can be a nice feature on a site. The next opportunity that may exist on your project to optimize the site potential is to consider energy implications in site selection and building orientation, such as perhaps you might be in a locale where there is an opportunity to utilize the solar heating for natural heating of your building, and to take advantage of that solar energy for passive heating of your building, you in the northern hemisphere need to have your building oriented so that the you have a long side, so to speak, facing south, because that's where the sun is in the northern hemisphere in the winter when you want heating in your building. And so orienting your building to take advantage of that option might be something that you could do. Also, if you are going to try to use solar energy for passive heating purposes, you need to pay attention to where the trees are on the site, because you don't want them to be shading the windows on the south exposure in the winter. On the other hand, it would be nice to have trees located where they would be shading the other exposures of the building and the roof, so that you would get have a better environment for cooling the building in the summer when it's hot outside. Similarly, perhaps your site has some prevailing winds, like the area that I live in California, has a natural afternoon breeze that comes up from the Sacramento-San Joaquin Delta, and very nicely cools off the area where I live in the evenings. And so you might want to think about where the natural ventilation exists, if it does exist on your site, and orient your building so that you perhaps would have some openings of some sort analogous to a window that you could open and take advantage of natural ventilation. Another possibility may be daylighting of your building using the natural lighting from the sun to light the interior of your building during daytime hours. If you want to try to do that, you have to pay attention again to where the trees are, because you wouldn't want your skylights being in the shade during daylight hours. You'd like to have them able to capture as much of that natural lighting as possible. Also, you would want to pay attention to the possibility that future development around your building may have some impact on your site. This is just a little sketch of the typical elements in a building if you are going to try to take advantage of the solar energy from the sun to passively heat the interior of your building in the winter when you want heating. South-facing apertures, windows that is, typically some kind of shading mechanism so that you can shade those south-facing windows in the summer, but have the sunlight pass through those apertures unimpeded in the winter. And then thermal mass and some other features. And this is an example of taking advantage of the energy implications in a site in a kind of an industrial environment, one where there is obviously a lot of employee parking. And so you have a big parking lot, and the cars sit out there and they get hot during the day. Well, you can construct shade structures, as you see here, that provides shading for the cars. So there is some incremental benefit there from the standpoint of the energy consumed by the cars when the employees come out in the late afternoon and drive home. They don't have to use up quite as much gasoline powering their automobile air conditioning unit, because their car has been in the shade and hasn't gotten quite as hot. But then the key thing that has been done here is, on top of these shade structures, mounting photovoltaic collectors to capture the solar energy and convert it into electrical energy, which may be utilized on the site or possibly sold to the local municipality. And the college campus in the town that I live in has installations like this, and they can they can be done in a way that makes an attractive landscape type feature at an installation. This installation here is pretty utilitarian looking, but you can make these shade structures with photovoltaics a fairly attractive landscaping type feature. This is an illustration just, of course, of the daylighting option, something that we're seeing more and more, as you see in this photo, as a feature in big box type retailing facilities. Costco's and Walmart's and things like that are in many instances doing a good job of utilizing daylighting to reduce the amount of artificial lighting that they need during daylight hours, and of course that artificial lighting consumes energy in the form of the electricity. The natural ventilation option. The next possible opportunity is to use building design and landscaping techniques to reduce heat islands. Now, a heat island is something like an asphalt concrete parking lot. It gets really hot during the summer, and you probably, if you've ever walked on a barefoot on an asphalt crossed an asphalt parking lot, you know that asphalt really gets hot. Roofs, particularly big flat roofs like on industrial type buildings, are also another type of heat island. And these heat islands, they get hot and they retain the heat, and then that is an additional load on the air conditioning system for the building. So if you can reduce these heat islands, one way you might reduce the heat islands is to use those little concrete pavers that we looked at a few slides ago, and to instead of just using asphalt concrete paving. Another thing that is done really routinely these days, at least in warm sunny climates, is to provide planter areas in parking lots so that trees can be planted that will grow up and provide substantial shade for the parking lot, and therefore reduce the intensity of that kind of a heat island. With roofs, there are things you can do in the selection of the roofing materials, providing reflective roof membranes, or light colored or white rather than black. Black retains the heat, and that is a load on the air conditioning system in the building. Here are some illustrations of what is being done more and more in new developments, new urban and suburban developments, is the provision of landscape areas where, of course, the landscape area in and of itself is reducing the heat island, but also the planting of trees that when they grow up they will shade the parking lot, that sort of thing. So this is a common feature these days. There is a federal program called Energy Star that is jointly managed by the Environmental Protection Agency, I think, and the Department of Energy, and it's called Energy Star, and it's kind of a database of building materials and products, and you can go to that that database, and it's an online database, and you can research what are the best roof membranes that are available from this energy efficiency standpoint. So this is this resource that's available to you. There is something called a cool roof rating council. Now that's doesn't mean a really shuckin' and jivin' cool roof. It means uh, temperature. And anyway, this organization was set up to try and standardize the ratings of roofing materials for purposes of reducing the air conditioning load on the building. Department of Energy has something called a cool roof calculator for estimating cooling and heating savings for flat roofs, and that is something that I'm sure you, by Googling around the Department of Energy's websites, you could find that, and I'm almost certain you could probably download it for free. Another opportunity that may exist on your project is to minimize habitat disturbance. Again, something that's kind of difficult to quantify, but it is recognized as being an appropriate and a legitimate and a desirable thing to implement into projects, is minimizing the habitat disturbance. The more you leave the natural environment alone and leave the little animals and the birds and things like, and the fish, things like that alone, the more you are advancing towards the objectives of and the principles of sustainable design. So minimizing land disturbance, reduce the building footprint, and other options along that same line. Restoring degraded sites. Perhaps you may have enough money in your budget that once you get your building built, you can go out and restore a degraded site, underused parking lot, dig it up, plant it in native vegetation, and that is recognized as legitimate. Designing for sustainable transportation. This can be something as simple as providing bike racks for employees at the front door, or perhaps there's a bus stop out at the street, and designing into your site plan a nice, convenient, pleasant path for employees and visitors to use in moving from your building to the bus stop or the light rail station or whatever it is that is out there. Restoring degraded sites. A key point there is in revegetating a degraded site, you want to do it with native vegetation, drought resistant vegetation, and low maintenance or non-maintenance type of vegetation. The sustainable transportation, again, these little concrete pavers pop up here, and this raises a point that it's well to keep in mind, and that is that there may be a certain opportunity or opportunities that are applicable to more than one of the principles of sustainable design. And as I indicated earlier, those opportunities you might want to pay particular attention to, because they you are getting more bang for the buck, so to speak. Investing your money in a certain opportunity does something on more than one of the fronts of sustainable design. And coordinating site sustainability with safety and security, so on and so forth. Okay, now we get into a listing of resources that are available to you. And as I indicated, most of these are federally generated. Do not be turned off by that. They are good, solid technical and design guidance. And they are in all cases accessible online and in almost all cases free. And you would simply copy the name of the resource off this list, put it into your search engine, punch the go button, and you will end up at a site where the resource is described and is available. One of the particularly good ones is that first one in this slide, Federal Green Construction Guide for Specifiers. These are a lot of cut and paste provisions that you can electronically cut and paste, download them off the internet and copy them and paste them right into the various sections of your specifications. And these are requirements then that are part of your contract with the builder, and the builder has to do this or that, and the materials have to be thus and so. And these are a very useful tool for you, and so you might want to in particular look at those, and they are available free for downloading on the internet. And then the Department of Energy has something called the Greening Federal Facilities Guide, something you might want to look at. GSA has something called the LEED Applications Guide. LEED is, of course, the organization that awards these green building certifications that have become quite popular. So the Federal Green Construction Guide for Specifiers, good product. The Environmental Protection Agency, as I'm sure you can appreciate, is in the forefront of addressing this sustainable building issue, and has developed a number of resources that are available to you, and so you'll want to look at their websites and see what's available. The Army Corps of Engineers, not usually the first organization you think of when you think of environmental sustainability and sustainable design and this sort of thing, but actually they are in the forefront of this sustainable design enterprise, and they have a lot of good resources you can look for. GSA with their LEED application guide, a resource for optimization of site potential information. Okay, now moving on to the second principle of sustainable design, which is optimizing energy use. Conserving energy, use as little as is reasonable within the constraints that are required of your building, and that understanding that the whole reason for designing a building is to provide a pleasant, efficient, safe, healthful environment for people to live, work, and work in and visit. So opportunity that may exist: reduce cooling, heating, and lighting loads by using climate responsive design and conservation practices. Maybe the location of your building is such that you can use solar energy passively to heat your building in the winter. That's not going to be the case in all geographical locations for climate reasons, and I don't want to get into that because that's really a whole different topic. orient size and specify windows to maximize energy efficiency. If you're going to try to use solar energy passively, big windows on the south exposure, uh, small windows on the west and east exposures, and sort of medium-sized windows on the north exposure. Use high performance materials in the building envelope. That means insulation typically. So well insulated buildings, a fundamental way of reducing energy consumption for heating and cooling purposes. Locating landscaping with solar energy and building load requirements in mind. And here again is just a picture of the elements in a building where you are attempting to take advantage of solar energy to passively heat the building in the winter. And you are seeing some of these slides that we saw uh, representing opportunities that existed in addressing the first principle we were talking about, and here they are popping up again. So if one of these opportunities exists, you might want to look seriously at taking advantage of it, because you will be getting more, quote, for the buck. Daylighting pops up again. Energy Star again is a resource, a database, and the the opportunities for energy conservation in building design have been evolving now for a few recent decades. And there are lots of things that are available. Solar water heating, very common thing we're seeing on residential buildings and on small commercial buildings. Very effective and a good way to reduce the energy consumed in the water heating. Photovoltaic devices, collectors to generate electricity that you may be able to use on site or sell to the water or the power utility in your area. The solar collectors, there's some details here, or some discussion of the different types of hot water heating systems that utilize solar energy, and you can look at these at your leisure. The photovoltaic devices, these are the the city that I live next to, or right in really, Davis, California, the University of California's large campus is there. And I just saw something in the paper that they've entered into an agreement with a company, and the company is going to construct a large photovoltaic plant. It's going to cover quite a substantial amount of land, and it will generate, I think this article said, about 15% of the UC Davis campus's power requirement, if everything goes the way they hope it will go, and I'm sure it will. So I mean, and that's a big chunk of money, because this is a campus with an enrollment of about 35,000. So this is a big campus, and generating 15% or so of their total energy need from solar energy is pretty impressive. Biomass is not something you're going to encounter very often, so we'll kind of just slide right by that. But that would be something that perhaps, if you have a project in an area that whatever's going on there generates a lot of biomass, like an agricultural area, and you can burn that biomass as fuel to generate electricity for your facility, well, that may be an option. Geothermal heat pumps, pretty exotic, probably not going to do too much with that. Um, and another option, and this falls into the O&M category, but it's to consider purchasing electricity from renewable and low pollution sources. And many utilities are now set up to do this. In other words, you agree to pay typically a somewhat higher rate for your electricity, and then the utility commits to purchase that increment of power that you are going to need from a renewable low pollution source, wind farm, photovoltaics, etc. And in that way, you are, out of your own M budget, are subsidizing the development of wind farms and photovoltaics and this sort of thing. So that's something that you might be able to do in the O&M enterprise. Now, an area where there has been very substantial improvement made in the last 2 or 3 decades is in the industry that provides the equipment and the energy consuming products that go into buildings, like as an example, illumination, artificial illumination. Well, not too many years ago, the rule of thumb for energy consumption in a typical office environment for the lighting was around 2.5 watts per square foot. Now that's when you had a large percentage of incandescent lamps. But with the improvements in energy efficiency of the lamps that are now used in interior illumination situations, fluorescence, and some of the even more exotic lamps, that rule of thumb is now down around 1 watt per square foot. So that's been a big improvement, and it's just due to improvements in the industry and the products that are made available to the building designer. You can go to the Energy Star website and see what the most energy efficient products are for various applications in buildings. There's been great improvements made, for instance, in energy efficiency of HVAC equipment, chillers, air handlers, fans, so on and so forth. Also, keep an eye open for energy recovery systems. Perhaps you have a steam heating system or a hot water, high temperature water heating system. Well, uh, after the high temperature water finishes warming up the building, the the high temperature water is still pretty hot. So you may be able to use that high temperature water through energy recovery to do something else, like preheating industrial water or preheating domestic water systems, so on and so forth. Maybe you might have an application for other kind of exotic things, cogeneration, fuel cells, thermal storage, etc., etc. Keep your eyes open for those. Another area where there has been very important advances made in the optimizing of energy use is as we have moved into and progressed through the age of the personal computer and now the internet, this sort of thing. And this has allowed the development of very useful and important programs of various sorts that can be used to optimize energy performance of buildings. One category of them is used in the design phase to model buildings, if you will, their energy performance characteristics. The so that you can in the computer program plug in different items of equipment with different efficiencies, and on the computer simulate the performance of the building over a 1 year cycle, and see which combinations of features, both mechanical, electrical, and architectural, result in the most energy efficient package. So those programs are readily available, as we probably already all know. But then the other category is on the operations side, energy monitoring and control systems that operate the energy consuming features of your building in the manner that is most energy efficient. Turn the lights off automatically, turn the air conditioning system off, or lower the temperature, or whatever, things like that. And digital control of boilers and chillers. And so lots of important products have been developed in this area of digital control. The there are products available that have been developed by government agencies, and this is just something Building Design Advisor. Here's something developed at MIT. Energy Plus is a program, an energy modeling program developed by the Department of Energy, and I think you probably have to pay something for that, but CAD program, Green Building Studio, and another point on the O&M side to keep in mind is the importance of monitoring the performance of your building when it is in operation, because there are almost always opportunities as you move along in the operation of a building, opportunities to tweak your, say, energy management and control system. Here are some resources available to you. Some of them you've already seen as being resources available in dealing with the earlier principle that we talked about, and you just need to explore these. Department of Energy, of course, is in the forefront here. There is something called the National Renewable Energy Laboratory, which is operated by the Department of Energy. It is located in Colorado, and it's a primarily research oriented, but there may be some approaches that are discussed here that you might be able to put to work in a real project. The Energy Star site is, of course, a database that can be searched to find the most energy efficient equipment and products that go into buildings. General Services Administration, of course, is the entity that designs and builds the routine buildings for the federal government, the office buildings, courthouses, things like that. Okay, the next principle of sustainable design is protection and conservation of water. And I kind of prefer to talk about utilization of water rather than conservation, to get across the point that the water system on the planet is pretty much a closed loop system, and what we want to do is utilize the water in ways that minimally consume resources. And that takes place to a significant degree in the treatment of the water before it's used by humans, and then the treatment of the wastewater after it has been used by humans, and then perhaps also upstream at the water resources end to capture and manage water so that it can be used by humans when it and is available when they want to use it. So reducing, controlling, and treating surface runoff. We've talked about kind of already the reducing and controlling. The treating of runoff is something to keep in mind. If the runoff from your site is going to, because of what's going on there, contain grit or oil, things like that, you might want to seriously consider designing into your site grit capture chambers or oil separation chambers to capture the grit and the oil and prevent them from moving off the site in the runoff. And like an example of where this happens frequently is with parking lots, asphalt concrete parking lots. They just naturally attract grit and scummy stuff, and including oil. And so if you can grade your parking lots so that the runoff is channeled through a grit separator and perhaps an oil separator, then that might be a good option for you. Green roofs is and then the grading of the site, and here you see examples. Natural vegetation holds the soil on the site. Grading swales so that the rainwater is held on the site and guided into like a rock bed, and there the water percolates down into the groundwater and stays on the site, and that's recognized as a desirable feature. Integrated pest management is something that is in the O&M side beyond really what we're talking about. The green roofs business is something that is kind of popular with people that have never had to repair a leaky roof, and that's why I'm not particularly enamored of them. And it's because with the green roofs, you're intentionally retaining water on the roof to make the grass grow and this sort of thing. And roofs leak, and water is absolutely amazing in its ability to find its way around nooks and crannies and leak into the interior of a building. Also with this green roof business, something you need to be aware of is that sooner or later you're going to have to replace the membrane on the underlying roof structure. So that means you're going to have to rip off all of this cute green roof stuff to get at the membrane. So a lot of cost there. The one application that I think looks perfectly reasonable is the one illustrated here, and that's the green roof on top of the chicken coop. It provides a nice, more comfortable environment for the chickens while they are laying their eggs, and you don't really care if the roof leaks because the chickens don't mind a little leakage when it rains. So a rough type of an environment like this for a building of this rough nature might be something where a green roof would be appropriate. But on more conventional buildings like the one in the middle illustration here, I kind of question the wisdom of going to that extent. Now in the protection and conservation of water, reducing and controlling and treating surface runoff. This is an example of what has been done in an industrial type environment. A lot of concrete all over the place, and asphalt concrete. And so when it rains, all of this rainwater just rushes off the site and discharges into the municipal wastewater system. That can create problems downstream for whoever's managing the municipal wastewater undertaking in this community. But here the rainwater on this site is channeled to collect into a retention pond, and then it is released slowly over time, so it reduces the surges in the quantity of stormwater runoff. This can be particularly important if if the surrounding community has a combined stormwater and wastewater collection system that channels all of the stormwater as well as the wastewater into the wastewater treatment plant, because big surges when it rains create operational problems for the wastewater treatment plant. So it may be necessary and appropriate and a good idea to go to the expense of designing in a stormwater retention feature like this. The EPA's Green Infrastructure Guidelines has some discussion of things that may or may not be available to you on your project. Rain harvesting is actually something that can be done pretty cheap on lots of buildings, even down to the scale of residential buildings, because the typical building design includes a rainwater collection system, gutters and downspouts. And as originally developed, the gutter downspout features just discharge the water to grade around the building. But if you go to a little bit more expense and channel that rainwater into a storage facility like a tank or even just a barrel and capture that storm water, it's high quality water, and you can save it and you can use it for landscaping purposes, irrigation purposes during the summer when you need it. And other features here that are mentioned are also ones that apply to the earlier principle we've looked at. Use water efficiently. I mentioned the important advances in efficiency that have come along in the last few decades in the area of energy consuming items in buildings, air conditioning equipment, illumination lamps. Also, there have been big improvements in the plumbing fixtures that are utilized in buildings these days. They are much more water efficient than they were not that long ago. For illustration purposes, a toilet, a water closet, prior to 1992, typical water closet used 4 to 7 gallons per flush. Today, the rule of thumb, and indeed it's incorporated into plumbing codes, is 1.6 gallons per flush. Similarly dramatic, equally dramatic improvements with things like urinals, faucets on sinks used to be 5 to 7 gallons per minute. Today, about half a gallon per minute. Shower heads used to be in the 4.5 to 8 gallons per minute, now down about 2.5 gallons per minute. So big improvements there, and very easy for you to specify these requirements in your specs. Protection and conservation of water, of course, if you can use drought-resistant plants, then you don't have to irrigate them. Therefore, you are using less water. So that's good. And this is one that you probably won't be dealing with every day. Certainly not this magnitude of cooling tower. So that we won't bother talking about a great deal. Using the water efficiently. I mentioned, of course, earlier the Department of Energy and EPA's Energy Star database website. There is a comparable website managed by EPA called WaterSense that is a database of devices that are used in building design that consume or utilize water, faucets and toilets and this sort of thing. And you can just go to this database resource, find out what the most water efficient faucets are, and you just specify. Protecting water quality, of course, paying attention to what you add to the wastewater stream, avoiding adding toxic or otherwise undesirable products to the wastewater stream, recovering non-site and gray water for on-site use. That's the rainwater capture approach. Design waste treatment and recycling programs. This is kind of crops up in the construction phase, and then in the O&M phase. In the construction phase, simple little things like specifying that the contractor pile the concrete waste over here, the metal waste here, the soil here, and the garbage over here. That facilitates the and may open opportunities for to sell the waste to recyclers, and it facilitates their picking up the material that they are concerned with, metal or concrete or whatever. And then in the O&M side, similar segregation of waste that is generated in the operation and maintenance of the building, provide sorting at the site to the degree that it is not unreasonable. Resources that are available to you. Again, a listing, and these can be used by you as tools. And as always, Department of Energy is right there involved, EPA and its WaterSense database resource, very important. EPA has a wastewater management program site with resources available. Now we come to the fourth of the principles of sustainable design, and this is the selection and use of environmentally preferable products. To a large extent, this means utilizing, specifying recycled materials and products for incorporation into your building, or designing features into your building that may allow things to be recycled in the future for some other purpose. So the opportunities, well, of course, one of the first that we saw in the first principle, and that is to, instead of building a new building, renovate an existing building. So you just plain don't use as much in the way of materials. There are some tools called life cycle assessment tools that are out there that undertake to evaluate the environmental preferability on a life cycle basis of different resources or products. Maximize the recycled content of all new materials. You can after doing appropriate research to assure yourself that products that you need for your building are available with recycled content, are available on the market. Then you just simply specify in the specs that the contractor shall provide such and such product with such and such percentage of recycled content, things like that. The and there are other things that you can do. Perhaps if you're repaving a parking lot, you can recycle the asphalt concrete, perhaps. And so that's maybe an option on your project. There are, as I was indicating, there are products on the market that have certain percentages of recycled content, like outdoor furniture. Plastic furniture is one that you're seeing a lot of, and it's a lot of that plastic furniture now has substantive percentages of recycled plastic incorporated into them, and you can just specify that kind of furniture. Specifying materials harvested on a sustainable yield basis. For example, lumber that you use on your project. It can certainly be reasonable to specify that the contractor provides certification that the lumber that he's using on the project came from a sustainably managed timber farm. And that's an easy thing to incorporate into your specs, so that the timber is being harvested on a sustainable yield basis. Buying locally can be something that you can do. If you have a project to build a building in California, it's going to have lumber in it. You can specify that the lumber be procured from a forest within 300 miles, say, of your job site, so that you don't end up buying a truckload of lumber in Massachusetts or Maine and trucking it all the way to California with all of that fuel consumption that would be involved in driving the truck. So, quote, buying locally can be an approach. And encouraging the use of recyclable assemblies are things that you can salvage from demolition of other buildings or structures and incorporate them into your structure. And you tend to not associate this kind of reuse of building elements with high-end residential construction. However, the Wall Street Journal a while back had an interesting little feature on high-end residential developments that had a high recycled content in them. In other words, timber that was salvaged from another building is incorporated into this one, things like this. So this is a $2.4 million home in Bozeman, Montana. This is an apartment in Long Island City, New York, that has recycled content. Spring Island, South Carolina, 2.2 million, has significant recycled content. So it can be done. Limit construction debris. This is sorting of construction debris and demolition debris at the site is something to consider and probably specify on projects. Eliminate the use of materials that pollute or are toxic. That is, and giving preference to locally produced materials with low embodied energy content. In other words, don't buy the lumber in Georgia and truck it all the way across the country to build a house in Oregon, because there's plenty of forests in Oregon where you could get your lumber from. Resources that are available to you, a listing again of these resources, and the EPA and the Department of Energy are, of course, forefront in this area. The Defense Logistics Agency has a green procurement program that you might take a look at. The Defense Logistics Agency buys the stuff that is used typically in the O&M of buildings, the toilet paper and things like that. And finally, the last principle of sustainable design is enhancement of the indoor environmental quality. And yes, this does not directly address the sustainability concept, but it's very important for you to pay attention to this, because that's why you're designing the building in the first place, is for the benefit of the occupants. And so yes, you could eliminate the air conditioning system, save a lot of energy and the consumption of the associated resources to generate that energy, but you'd have some very grumpy occupants in that building. So some things that you would do along this line is value aesthetic decisions. In other words, don't design an ugly building if you can do a little here and there to make it more pleasant for the occupant. You want to do that. Supplying adequate levels of ventilation and outside air, that's very important for occupants. Yes, you could save energy by not bringing outside air into the building for ventilation purposes, air quality purposes, but very rapidly the air quality inside the building goes in the tank and gets smelly, unhealthful, humid, so on and so forth. So you don't want to do that. And that same air quality issue can lead to issues of bacteria and mold and bad stuff, limiting spread of pathogens, and avoiding use of materials with high levels of pollutants. Assuring acoustic privacy. This is something that I've always felt is certainly important in building design, and that people just work better if they're not constantly being disturbed by conversations going on around them. That's why I've always never been much of a fan of open plan offices with all of these little cubicles that people are stuffed into, because the acoustic environment is poor. And also, yes, you can save money by cutting down on the amount of illumination, artificial illumination that you have in your building, but then that's an inefficient, unpleasant working environment. Now you can do a lot to both provide a high quality illumination environment and save energy by moving more towards spotlighting. In other words, instead of relying on those overhead light fixtures, maybe you can reduce the lighting level provided by those ceiling fixtures and use more desk level lighting for employees, and that can work well, providing the appropriate water quality, controlling disturbing odors, and some resources that are available to you here. Now, a number of these are the ASHRAE ones, American Society of Heating, Refrigerating, and Air Conditioning Engineers, because they are the lead entity in the area of thermal comfort and air quality in buildings, and they have a number of standards that apply. So the resources and the usual suspects, EPA, OSHA, and now these slides here I'm going through quickly are from the design, the green specifications designed specs, guide specs produced by the federal government, and I just flipped through those to kind of show you the degree of detail that they provide. And then there is the Green Building Council with their LEED program that has been so effective for them. And finally, what do you do with all of this stuff I've been chatting about? Well, what I think is you can do is to take these things I've talked about and develop a checklist of the principles, the opportunities that exist with the different principles, and then when you're in the concept stage or preliminary planning stage with a project, you sit down with your checklist and identify those opportunities where you might be able to do something on your project. Leave them on the list, cross off the other ones that just plain aren't going to exist on your project, and then to focus your time and energy and budget on those opportunities that may in fact exist on your project. So this checklist concept, I think, is worth thinking about as far as something that's useful. And that is the end of my story for today, and I hope that this has been somewhat interesting and hopefully somewhat useful to you, and will better prepare you to move forward and incorporate these concepts of sustainable design in your future projects. So thanks a lot, and have a nice rest of the day.